Hi, my name is Mr. Rupp. This is Pre-Algebra, and we're studying 7-5, volume of prisms and cylinders. Okay? So the first thing that we need to understand about volume is what area is. Okay? If I put up this chart here on the notes about the area of a shape. Okay, so the area of a shape is the measure of its surface. Now we're talking about two-dimensional shapes: squares, rectangles, triangles, parallelogram, the trapezium, which is a trapezoid, rhombus, a circle, or a sector, a piece of a circle. Okay, those are all two-dimensional shapes, and area is related to that. All right, so when we get to volume, we'll take the concept of an area and expand it into 3 dimensions. So right here we have a definition of volume. Okay, volume is the measure of the space occupied by a solid. You've heard of volume before, right? It's measured in things like, okay, cubic inches. Well, what does that mean? All right, when you see cubic inches, well, what that means is that if you would take a little cube, okay, just like this, okay, and each of the sides is 1 inch, okay, and whatever box or rectangle that you have that's made into a 3-dimensional shape, you fill it for as many of these little cubes as you can, and each of these is a cubic inch. All right, so that's why we call it inch to the 3rd power. You can have centimeters, cubic centimeters, cubic feet, all right, cubic meters, and it's all about to the 3rd power. To the 3rd power means cubic. Okay, so then that brings us down here to the volume of a prism, a key concept. Yay, key concepts, we love them. All right, and the key concept here, it says that the volume V, always with a capital V, of a prism is the area of the base times the height. Okay, now prisms are 3-dimensional rectangles and triangles. Okay, you can have a rectangular prism, you can have a triangular prism. Okay, I'm sure you could have a trapezoidal prism, things like that. When you talk about circles, that's a different story, and that's it has its own name for the 3-dimensional portion of it. Okay, so for a rectangular prism, okay, you start out with a rectangle, all right, and you take the area. Well, the area is equal to the length times the width, right? The area is equal to the length times width. But what we do now is we extend this into 3 dimensions. We take this area right here and we extend it down 3 dimensions. Well, the area of this piece right here is now called the base. All right, now I drew it on top because that makes it easier to see what it is I'm talking about. All right, but the base is the base unit, the rectangle that we're talking about, and that the area of that. And then we take that area and we extend it into the 3rd dimension, and we call that the height. All right, so you take the area and you multiply it by the height, and that gives you the volume. Okay, and that's why over here you have volume is equal to capital B times H. And here you see capital B is the base. Here they put it on the bottom because that's typically where your mind is used to seeing a base, is at the base of a pillar, so to speak. And then you extend it up. Basically, you are pulling it up into 3 dimensions. Okay, you can think of it that way. The same thing goes with a triangular prism. Okay, And the area for a triangle, remember, is 1/2 little b times height, okay? Like this. And this is the height, and this is the little b. This is the base of the triangle, okay? Well, now, when you turn this into a prism, and I'm not good at drawing triangular prisms, all right? That little b is part of the base, all right? It's the little triangle. But now, when you talk about the triangle of a triangular prism, then that turns into the capital B base, and you extend that up, or out into 3 dimensions. So basically, you're taking the triangle and you pulling it up into the 3rd dimension. Okay, that's what the height is, the h. All right. So let's work some examples, because that will make life a little easier. Okay. So here we said to find the volume of prisms. Remember to always start by writing down the formula. Okay, it gives you a place to start, and it kind of anchors your brain, your mind in the problem. Okay, so we've learned that the volume of a rectangular prism is capital B times H. Now, capital B was the area of the base. Now, it doesn't matter which face of this you choose as the base, so long as you know what the other dimension is, the height. All right, so in this case, let's choose 5 and 9 centimeters as our base object. Okay, so down here we're going to say the base is equal to 5 centimeters times 9 centimeters, and that gives us 45 square centimeters. That's the base area, the area of the base. Now we go back up to our formula up here, and we say now we need to know what the h is. So V is equal to capital B times h, which is 45 centimeters squared. And what's the other dimension that we haven't looked at yet? We haven't touched 6.5 centimeters. Okay, so 45 times 6.5 is 292.5 centimeters, and here you have a centimeters squared times a centimeters, so that's centimeters 2 plus 1 centimeters cubed. Okay, not so difficult really. Okay, rectangular prisms are actually pretty simple, and triangular prisms are not much harder. So here it says find the volume of the triangular prism. Again, volume is equal to the base times the height. Capital B base. Well, what's the capital B base in this picture? Well, we know that it's a triangle, right? We know that the area of a triangle is 1/2 little b times h. Well, what would little b be? Little b is the base, 6 inches. And h would be the vertical height of the triangle. In other words, that's 7 inches that they're talking about. Okay? So the area of that base of that triangle there is 1/2 times 6, the base, times 7, the height. And that's equal to 42 times 1/2, 21 square inches. That's the area of the base face of that triangular prism. Back to our formula then, V is equal to BH. Okay, we just calculated the capital B, the base. That was 21 square inches. And we multiply that by the H. Now in this case, the H is the 10 inches. That's how you're basically pulling that into the 3rd dimension. All right, 10 inches. So 21 times 10 would be 210. Inches squared times inches gives you inches to the 2 plus 1, or inches to the 3rd. And there you go. Okay, moving on. Now, Remember when I said that circles pulled into the third dimension have a name of their own? Okay, you could call them circular prisms, but they have their own name that in English from our history. Okay, and they're called cylinders. All right. So the volume V, capital V again, of a cylinder with the area of the base B, or is the area of the base B times the height. Same exact concept, okay? So you take a circle, all right, like this, and the area of this circle is pi r squared, right? Pi r squared. So here is the radius, that's the r, and we know what the area of this guy is now. So now what we do is we take and we extend him, pull him into the third dimension, okay? And this now becomes the h, okay? So the b that they're talking about here, the b is pi r squared, because that is this two-dimensional object that they're referring to, the circle. So you take the circle and you pull it up into the third dimension, an h amount, okay? Or sideways, it doesn't really matter. Okay, so let's do an example then. Okay, so we're gonna, example 3, we're gonna find the volume of a cylinder. And we're supposed to round to the nearest tenth. So again, the first thing we do is we write down our formula. The volume is equal to the base times the height, capital B base. Well, the base for a cylinder now is a circle, and so we know that the area of a circle is pi r squared. Looking at our picture here, are we given the radius? Not directly, no. We're given a diameter. D is equal to 13 feet. Well, a diameter is 2 radii, okay? It's 2 radiuses put together. So if we want to find the radius, we take half of the diameter, okay? So the radius is equal to 1/2 times 13 feet, or 6.5 feet. That's the radius. So we come back over here and we plug in pi times 6.5 quantity squared. All right, so 6.5 squared gives us 42.25 pi. So now taking it out of its exact form, which has the pi symbol in it, putting it into something approximate, we have 42.25 times 3.14159, and that's just the approximation I'm using, and that gives us approximately 132.7321. Now, there are more digits than this 7321 here, but I'm going to use 4 digits because we're not at the end of our problem yet. This is not the point that you round. So you carry as many digits as you can, and 4 is typically enough, and then you round at the end of the problem, not here. Alright, because now all we have done is we have found capital B. So now we have to go back and take that and plug it into our formula. Volume is equal to capital B times H. Okay, so capital B times H is equal to 132.7321 times H. And H in this case is the height of the cylinder, which is 20 feet. Okay, and I didn't put feet squared in there, but there it is. Okay, so we take these two and multiply them together, and what we come out with is 2654.64 feet squared times feet is feet to the 2 plus 1, or cubic feet. Now they want us to round to the nearest tenth. So we look at the 4 here. I should do that the other way. They want us to round to the nearest tenth, so we should look at the hundredths place, the 4. 4 is 4 or less, and therefore that means that the 6 stays the same. So our final answer then is 2,654.6 cubic feet. Now you can say those units as feet cubed, or you could say them as cubic feet. They mean exactly the same thing, and they are interchangeable, so it doesn't matter. You can also write, instead of feet to the 3rd power, you can write down cubic feet right over here. Okay, you could say cubic feet, and that would be perfectly acceptable too. Moving on. And now we come to the last part of this section, and that is the volume of compound figures, composite solids they call them. Okay, now just like when you were dealing with area and you had like a 2D shape of a house where you had a square and then you had a triangle sitting on top of it, and they wanted to find that whole entire area. Okay, that was the area of composite figures, compound figures. Here is the same thing. You've got two geometrical shapes, two three-dimensional shapes that are related somehow, and they want you to find the overall volume. So example 4 then. And it says find the volume of this composite solid. And it says Tanya uses beads shaped like cubes to make jewelry. Each bead has a circular hole through the middle. Find the volume of the bead. All right. So this is a multi-step problem. Okay. The overall problem here is what? Well, you've got two different shapes, right? You've got the volume of the cube. Okay. And that's going to equal the base of the cube times the height. And that's one. And then the other geometric shape you have is the volume of that cylinder. And that's going to equal the base of that cylinder times the height. Now you'll notice in this case that the height is going to be the same for both of them. If you look at the picture, you'll understand why. So H is the same for both. So the overall volume of this composite solid then, okay, the volume of the composite is equal to what? It's going to be equal to the volume of the cube less the volume of that cylinder drilled through the middle of it. So in other words, it's got a cube and you drilled a hole through that solid. You basically have removed that material. So you've removed it out of the volume. So the cube, the total volume is that cube minus what was ever, that cylinder, that hole you drilled through it. So this is our top level formula right here. Okay, the volume of the composite figure is equal to the volume of the cube minus the volume of the cylinder. Well, now that we have it broken down into that, now we can go about figuring out the pieces to it. Okay, so let's go about figuring the volume of the cube. Okay, and there we say that it's equal to the base of the cube times the height. Well, what's the base of the cube? The base of the cube is this 12 millimeters by 12 millimeters, right? Okay, so the base is equal to 12 millimeters times 12 millimeters, which is equal to 144 millimeters squared. Aha, you say. But what's the height? The height isn't 2 millimeters. That's the only other number we've got there, right? Well, that's true. The height is not 2 millimeters. But there's a word used in the original problem, okay? And that tells you that gives you the clue we need. It says Tanya uses beads shaped like cubes. Okay, a cube is a square that's pulled up into 3 dimensions. Okay, just like a square has all of its sides the same, a cube by definition has all of its sides the same, which means then that the height is also going to be 12 millimeters. Okay, and I will write that in red up here. Therefore, the height, h, is also equal to 12 millimeters. So now down here we have the volume of the cube is equal to the base, capital B, of the cube times the height. We just figured out what the base was, calculated it, so that was 144 square millimeters. And now we multiply it by the height, which is 12 millimeters. Okay, so 144 times 12 is equal to 1,728 millimeters. We have millimeters squared times millimeters, so that's millimeters to the 2 plus 1 millimeters cubed. All right. Okay, so up over here, we're going to talk about the volume of the cylinder. All right, now we learned that the volume of the cylinder is equal to, again, the base of the cylinder times the height. So now what is the base equal to? Well, base is equal to pi r squared. So we have pi. Now what's the r? Well, if you look real close up there, you have a 2 millimeter hole. 2 millimeter goes from one side to the other. That makes that measurement a what? A diameter. Therefore, that the radius, okay, of this object is 1 millimeter. Okay. Over here then, we have 1 millimeter as our radius, and that's squared. So substituting 3.14159 for pi, 1 squared is 1. So you have 3.14159 millimeters. I'm running out of space over here. Millimeters squared. And that is our base, cylinder base. Okay? So the cylinder now, the volume of the cylinder, that little cylinder, the hole drilled through there, is the base of the cylinder times the height. The base of the cylinder now is 3.14159 millimeters squared. And what's the height? The height is the same as the cube, side length. Okay, that hole is as long as the cube is, so therefore the h is again 12 millimeters. Okay, so that equals approximately 37.699. Well, that was bad writing. Cubic millimeters. That's the volume of that little hole drilled through the cube. All right, that's the volume of the cylinder. So now we have the two different volumes of the pieces that make up this composite solid. So now our volume of the composite is equal to the volume of the cube subtracted out the volume of the cylinder. So the volume of the cube is 1,728 cubic millimeters, and you're subtracting 37.699 cubic millimeters. All right, and that gives you approximately 1,690.3 cubic millimeters. Okay, So a couple of things here. Remember, do not round any of your figures in your problem until you get to the very end of the problem. Okay? So it can throw off your final answer. Carry 3, in this case we had 3 digits that meant anything, so the 0.699, so I just carried them along. If you're worried or you don't know, carry 4 digits past the decimal point, unless there isn't one. Okay, one of the previous problems, the answer came out to 42.25. That was the answer. It ended. So carry 42.25. Those 2 digits will be enough. All right, don't make them 42.2500. That doesn't mean anything. Okay, that's it for now. Thank you for watching this to the end. If you have any questions, be sure to email me and I will get back to you. Good luck with this and happy Memorial Day. Bye.